So I'm Rich Bentley. I lead product marketing at StormForge. Really happy to be with you today. And in the next 15 minutes, what I want to do is give you an overview of the StormForge platform. So Kubernetes is complex. You've probably heard that phrase over and over again from vendors like us, for the most part, in different contexts, maybe related to security or networking or scaling. And when StormForge was founded, actually in 2016, so we were essentially a machine learning lab. We had a bunch of PhDs and data scientists, and they were applying their machine learning expertise at the time to data center power optimization, helping data centers become more efficient in terms of their power utilization. In 2019, our development team was porting their code from Docker Swarm over to run on Kubernetes. And they realized at that point that Kubernetes really is complex, and especially when it comes to resource management. And you can see why that would be, because when you deploy an application on Kubernetes, there are a lot of different resource settings you have to configure. CPU requests and limits, memory requests and limits, replicas, and then there's application-specific settings as well, things like JVM heap size, garbage collection, all those type of things. And if you add all that together and multiply it by the number of containers that make up your application, the number of combinations is essentially infinite, or it really is approaching infinity. And if you also think about the fact that every combination of settings is going to result in a different outcome. And when I say outcome, I mean the performance of the application, the availability, and the resource usage or cost of actually running the application. So what happens then with that kind of complexity is you have to make a choice between three things. Over provisioning. So a lot of companies, as they start using Kubernetes, they tend to over provision just to be safe, right? They don't want to risk any performance issues. And that may work fine in the beginning, but as you scale up for day two operations, that becomes a really costly proposition. We're hearing about companies that cloud costs are 70 to 80% of their revenues, which is not really a sustainable business model, right? So the second choice you have is you can scale back on your resources, try to be more aggressive and frugal with the resources that you allocate for your applications. But at that point, you're introducing risk, right? Risk of out of memory errors, CPU throttling, things that are going to affect the user experience.
Rich, can I just ask a question? Wasn't it the premise of Kubernetes that scaling an application across multiple nodes was part of the design of the platform, and that if you'd written your application correctly, it should just scale up and scale down and you shouldn't have to care about any of this?
That is certainly the premise of Kubernetes, is to provide you a lot of flexibility to help do those things, but in actual fact, it becomes very complicated to do that. And
okay, so does that mean we're saying that users aren't aware of what they need to do, that they're not writing their applications correctly, or that we were sold a mistruth in the first place?
I don't know if we were sold a mistruth, but I think the reality is certainly more complicated than I think people believed in the beginning.
Okay.
The third choice that you really have is to take the resources that you have and ask them to tune the application and spend time actually tuning and making the application run more efficiently. The way you would want to approach that is very scientifically, right? You'd want to change one variable at a time, see how it reacts, then go back and change another variable. And that doesn't work very well for a couple of reasons. One is that these variables are all kind of interrelated. And second of all, the number of combinations that we talked about, it's just impossible to do that for a human. So when our team was porting their code over to Kubernetes, they realized that the machine learning that we were using to optimize data center power utilization, we could actually adapt that and use it to help address this problem as well. Machine learning is really well suited for this type of complex multi-variable optimization problem in a way that humans just can't approach. So they built a product released about 2 years ago called Optimize Pro. The way Optimize Pro works in brief is it works in a non-production environment, and it works by a process of experimentation. So it runs different scenarios, machine learning comes back and tells you what the best way is to configure your application. And it's a great way to learn, it's a great way to configure your application, but it's only one way to learn, right? Experimentation is great. Another way to learn is by watching what actually happens in production. And so that's why we built a second solution as part of the platform called Optimize Live. This is actually brand new. It's actually being launched on February 23rd. So for those of you who are watching this live, this is a bit of a sneak preview. But the way that Optimize Live works is it takes observability data that you're already generating and uses machine learning to help make recommendations on how to make your environment more efficient live in production. Let's dive a little bit deeper. Optimize Pro, as I mentioned, works in non-production environment. It's experimentation based. So what that means is that the first step in using this is to create a load test that is going to run the scenario that you want to experiment for. We have a load testing solution. You can use other load testing solutions. Once you have your load test set up, then you need to configure your experiment. And essentially that's a process of we scan your cluster, we tell you which parameters can be tuned, and then you tell us what goals you want to tune for. And a goal could be any metric you can measure. Typically it's cost and performance, right, are the two sort of primary goals that you would have. So you would use those metrics to configure your experiment. There's some other configuration options, but at a very basic level, that's it. Then you can kick off your experiment. When you kick off your experiment, the process is completely automated. So StormForge manages the experiment. So you can kick it off, you can come back a couple hours later, you can come back the next morning and see the results. The way an experiment works is there's a number of trials that make up an experiment. Could be 20 trials if it's a very simple app with only a couple of parameters that you're tuning. Could be 200 trials. And each trial consists of a process where, first of all, we start the application up in a non-prod environment. We apply load to it using the load test that you built before. We measure the results being those goals that you specified. And then our machine learning analyzes that and comes back with a new set of recommendations to try, updates the manifest, does the same thing over and over again. As the experiment runs, the machine learning, with every iteration, it learns more and more and gets a better understanding of this complex multi-parameter space of the application, right? And over time, it starts to home in on those configurations that are going to result in the optimal outcomes. And so what you end up with is a results screen that looks something like this. This is a simplified version with some things blown up. You'll see the actual product when Patrick goes through the demo. But every dot on this screen represents one of the trials in that experiment. And the result of that trial is plotted against your goals, in this case, latency and cost. The blue dot is where we started from. That's the baseline, right? That was the first trial that we ran, was with that baseline. And then the orange dots represent the optimal configurations that the machine learning is recommending. You'll notice there's not just one optimal recommendation, there's a set of them. And the reason for that is because you may have different priorities depending on your application and your organization. You may value cost more than you value performance, right? And if that's the case, you might choose something on the upper left part of this. You may value performance more, and in that case, you may not worry about cost, and you may choose something along the lower right. But we give you those options, and we do give you one in the middle that is sort of, if you valued both equally, that's the one that you should choose. So that's Optimize Pro. Optimize Live is a little bit simpler, right? It works in a production environment. And essentially what we're doing is we're applying machine learning to observability metrics that you're already generating. And we're using that to make recommendations for updating your CPU and your memory settings. So it's a little bit more limited. We're just doing that for now, but it's also super easy. As we update those recommendations, you can either have those automatically implemented, in which case we patch your deployment, or you can have an approval step that goes in the middle where we show you the recommendation. You can look at it, you can drill down and explore it a little bit deeper, and then approve it. That cycle continues to happen over and over again at a frequency that you configure when you set up the deployment. And so essentially, once you get to the point where you feel good about the machine learning recommendations, you put it on autopilot, and your application is essentially just maintaining efficiency as it runs in production. So just to kind of summarize, so Optimize Pro, experimentation-based, works in a non-production environment, uses load testing as the input. Optimize Live works in a production environment, observation-based, uses observability data as the input. Just a couple more points. Optimize Pro, because of the fact that it uses this scenario testing experimentation approach, it gives you a lot of control, a lot of power to do a lot of things. It's very flexible. You can tune for any parameter, for any goal that you can measure with any scenario that you can dream up and build in a load test. So super powerful. The other thing that's kind of an intangible is that a lot of organizations find that it provides them some really good insights into their application because it allows you to really explore and kind of understand the application and analyze it. You find some key things that help you improve the architecture of your application. Optimize Live, on the other hand, as you've seen, it's simpler. All it is tuning CPU and memory. As we saw, you can automatically implement recommendations or you can manually approve those. So it doesn't go as deep. It's not as flexible as Optimize Pro, but it's a lot easier because you're already generating this observability data. So, it's essentially just leveraging the data you already have. The way we see customers using these two is, Optimize Pro is probably something you look at for your top 20% of applications, the ones that are the most complex, the ones that are most mission critical, the ones that you want to invest the time and effort before you deploy to make sure that they're optimized and running efficiently. Optimize Live, then, you would still use on those, but then also on the other 80% of the apps, because it's very easy to do. You're going to get gains out of it, very, very easily. We like to use the analogy of GPS, right? When you are planning a trip, you go on Google Maps and you do all this work up front to plan, to look at the different routes. You might think when I leave on the trip, it's going to be rush hour, so I might want to think about this different route. That's Optimize Pro. Then when you leave on the trip, you've got kind of real-time adjustments, right? Lane assist and rerouting as, based on real-time information. That's really Optimize Live.
Quick question on this.
Yeah.
Can you go back one? So it seems like you've embodied the two approaches to this, right? You can either educate developers, platform teams about their actual workload requirements and help them make better provisioning decisions, or you can try to help transparently adjust and rectify those provisioning errors. And it sounds like you're doing both. You started out with Optimize Pro, though, in the latter approach.
Yeah.
Do you find that customers are wanting to be more educated or wanting more of the easy button type, fix the provisioning issues for me?
Yeah, it's a great question. So we're seeing a lot of success with Optimize Pro, but one of the most common objections is that it requires resource up front, it requires time and effort. Some people already have load tests built, they have QA resources, and that's great. But one of the most common objections we get is that we just don't have the resource, we don't have the time to do that. And so that's where the demand has really come in for something that's going to be easier to configure, easier to get started. And really, it's a good lead into actually the next slide, which is, what our goal is really to make this into, part of your standard DevOps process and make it a continuous, systematic process of optimization that kind of closes that loop between production and pre-production. The last thing I'm going to cover before I turn it over to Patrick, just a few things that we think are important as part of the platform and as you think about using machine learning to do Kubernetes optimization. One is that, we talked about the fact that you're generating a lot of observability data already. And what we find is that most companies, they have all this data, but they have a gap between observability and actionability, if you will, right? They've got a lot of dashboards, they've got a lot of information to see what's going on, but how do I actually take that and figure out what to do about it to improve my production operations? Second is we talked about the in-depth insights that you get with scenario planning and experimentation. And that's really important to help you, understand your application behavior, especially for cloud native applications. And we are the only solution that combines both of those approaches into a single platform. Third is the machine learning side of things. So really important to think about using, machine learning that is meant to solve this type of problem versus more of a basic kind of statistical approach. So there are other solutions out there. The vertical pod autoscaler, for example, that comes with Kubernetes is targeted at solving this same problem, but it uses a very basic kind of approach. It looks at averages over the course of time, and then it takes that, and if the average, real usage is over 95% or less than 50% of your current setting, it'll make an adjustment. It's not very effective, especially if you're in a very dynamic, variable environment where you'll find that it's always lagging behind and you're, resulting in resource slack, risk of performance issues. And then lastly is time to value, just thinking about, what it takes to actually configure and set this up. If you're having to do a lot of editing of YAML files. You kind of have to do a cost benefit analysis of that. The approach that we've tried to take with this is to make it very easy and automated, but at the same time, give you the ability to go in and fully edit the YAML file and customize any aspect of what you're doing with that.
Rich, what's your deployment model? Is it all on premises or all with the clusters? This isn't a SaaS model or anything like that.
It is a SaaS model. There's a component that runs on premise in the cluster that controls the experiment, but then the machine learning runs
a SaaS model.
As a SaaS model.
Okay.
Yeah. And we do have the ability to do an air-gapped deployment as well. So you don't necessarily have to send data over the internet. One thing just to point out is the analyst firm ESG did a technical validation of the product of Optimize Pro a couple months ago, and they did a nice write-up that kind of gives their perspective from a third party. So definitely recommend that.